So here we are, last material, last test, last Creswell test, last Creswell section, only 4 sections before this test. So here we go, graph theory. So we're going to start off with some vertices. So I'm just going to draw, so here would be vertex 1, here would be vertex 2, and here would be vertex 3. Okay, and then we're going to have edges. So this would be called edge 1, and this could be called edge 2, and this could be called edge 3. Okay, so a graph consists of 2 finite sets. There'll be a set of vertices and there'll be a set of edges. And each edge is associated with 1 or 2 vertices. So an edge doesn't go flying off by itself. It could come back to itself, or an edge goes between 2 vertices. And both of these are called endpoints. So this is an endpoint and this is an endpoint. Okay, so we have a loop. A loop in a graph would be here. If this was V1, this would be edge 1. That's a loop. And then this could be edge 2 going to vertex 2. All right, so 2 distinct edges are called parallel if they have the same endpoints. So if I've got V1 here and V2, this edge 1 is called parallel to this edge 2. Okay, 2 vertices are called adjacent if they are connected by an edge. So this V1, and if this is V2, so V1 and V2 are adjacent. So they're connected to each other, right? And if I have another edge, and sometimes we don't label the edges, sometimes we do. So this V2 and V3 are adjacent. And so V1 and V3 are not adjacent, right? Because they are not connected by an edge, one edge. Okay, and each edge, an edge is incident, it's just more words, right? Incident on each of its vertices. So this is vertex 1, vertex 2. So this edge 1 is incident on this vertex and on this vertex. And 2 incident edges on the same point, or 2 edges that are incident on the same endpoint, are called adjacent. So this is E1 and this is E2, right? So this edge goes, and the edges don't fly out by themselves. So there has to be a vertex here, and let's call this 2 and this called 1. So these 2 edges are called adjacent, right? The edges are called adjacent if they come towards the same endpoint, to the same endpoint here. A vertex where there's no edges, so I cannot have just an edge flying out there in space. Doesn't happen. But I can have a vertex standing alone, right? So vertices or edges have to be connected by vertices, right? Or you could have this vertex and this edge coming back, or you could have an isolated. So this is an isolated vertex, this right here, just kind of standing alone by itself. A directed graph has arrows on the edges. So if I had this vertex 1, and if I had this edge, if I put an arrow, that's giving me a direction. So this is just called a directed graph. And you can even have the arrow on a loop. Okay, so here's where we start to get important, so these are basic things. But now we're getting to really big deals. A simple graph, put a star by this, because a simple graph has no loops and no parallel edges. So we had to build up all this stuff, right? But now we're starting to get to the things. So a simple graph would be something like this, right? No loops, no parallel edges. All right, so now we're going to talk about these complete graphs. And K, they use the letter K because for the German word complete starts with a K. All right, K sub 2 is a simple graph, meaning no loops or parallel edges, and it has 2 vertices. So here's a V1 and here's a V2. So this is a simple graph with 2 vertices. So I want K sub 3, which is a simple graph with 3 vertices. and I'm not going to, it's not necessary to label all the vertices every single time, so I'm going to stop. So K4, a simple graph with 4 vertices. Okay, so there's one edge for each pair of vertices. So far it's been pretty straightforward, right? So one edge for each pair of vertices is going to change here. So I need to have an edge here, an edge here. So this pair of vertices has an edge. This pair of vertices has an edge. This pair of vertices has an edge. And this pair of vertices, this vertex and this vertex, has an edge. Okay, so let me change colors. So what about this vertex and this vertex? That pair needs an edge. What about this vertex and this vertex? That pair needs an edge. So every vertex, or every time you have a pair of vertices, then you need to have an edge. Okay, so I'm going to let you do this in Zoom. Let me make a note of that. All right, so then we're going to go to bipartite graphs. And let me stop there.